Is this even working? Wow, I like how I have no viewers right now. That's amazing. Um, so I guess I'll wait a minute and then start this thing. Wow, we have one chatter. What's up? I am now a new higher streamer for Rebel Vibe, so that's cool. Okay, so I guess I can start with the first problem if my audio's even working. Okay, so I mean, the first problem is just an implementation practice, right? So you have 100 light bulbs, and then the inputs get to give you some light bulbs to toggle on or off, and then at the end, you want to figure out what light bulbs are still on. And so what you can do is you could just make an array of length, I guess 101 because stuff is one indexed, and you can just iterate through the array and flip whatever it is, and flip the first bit of the integer in that array, right? And then that will result in you flipping that light, and at the end you see which one's uh, which one's still one in the on array. And I mean, yeah, this is like easier than a div 3a. Um, so I guess we can move on. There aren't any questions for this, right? I mean, I assume not. Um, okay, so for the second problem, I mean, it's also kind of just implement the statement, right? So you're given like an array, right? And then so you want the first element which the frequency is unique. And so what you should notice that you should first find the frequency and then determine that frequency is unique, right? And so what we can do is we can use a hash map. Yes, crazy. And so if we use a hash map to get all the frequencies, right? So that is this NP thing. And then we use another map to get the frequencies of those frequencies. So we know that if the frequency of the frequency is 1, then it's probably unique. And so we can just loop through the array and see which elements have the frequency of 1. And I guess that's that's it, I guess. Uh, pretty easy stuff. Probably like a div 3b, I guess. Um, I mean, these problems aren't even good enough to be in Codeforces, so I have no comments for them. Guess I'll wait a minute for any questions from how many viewers? The 9 people that are watching. Um, I hope you guys are alive and breathing. Okay, well, one person says no doubt. That's good enough for me. Um, so moving on to the third problem. I thought this problem was quite a bit harder than the other two, right? So for this question, you kind of have two parts. So a substring is almost palindromic if it's palindrome after at least after removing at least exactly one character from it. So what you should think about is what happens if we first remove no characters, right? And after we can have a way to figure out how to remove no characters, then we probably have a way to figure out what happens if we remove one character and see if that becomes a palindrome. So this is a pretty standard problem, right? So essentially, consider that this is exactly no character, then it's basically just find the longest palindromic substring, right? Which is like a really standard Leetcode problem that I hope everyone has solved. And so I'll just like reiterate what that means um, from like drawing stuff, yes. So what I did is you have a DP array, right? DPLR. And then this will give you, and it's note that the bounds are less than 2.5K, so you have a comfortable n square algorithm. And so DPLR represents um, is a substring bounded by L and R, a palindrome. And you should notice that, let's say some string is, we already know some strings are really a palindrome, like ABBA. If you add some same letters to the front and the back, right? So let's say we add like D to the front and the back, then you know that this is going to be a palindrome, right? So in other words, if dp l minus 1, I mean l plus 1 and r minus 1 is a palindrome, then we know dp l and r is a palindrome because only if s of l equal to s of r, because essentially we're just adding two of the same characters to like two of the same characters before and after the middle part. And so like what that motivates is kind of a DP where you iterate in order of length, right? Um, so if you know that the length 4, say you have a length 4 string here in the middle, then when you consider length 6, then you can directly transfer off this length 4 string in the middle, because you know that um, the length of this string is just r minus 1 minus l plus 1 plus 1, and you know that the length of this string is r minus l plus 1, and you know that the length of the string you're transitioning off is going to be strictly smaller. And so essentially this is just a transition for determining if something is a substring, a palindromic substring, considering that there is no deletions. But the problem asks you to determine an almost palindromic substring, which is like essentially almost the same thing actually. Um, so let's know another DP array, DP2 of L and R, that we're going to use DP of R actually. That is going to be true if S of L and R is an almost palindromic substring. So in this case, you want to consider deleting one character from DP L and R and seeing uh, if that matches like the current string. So your transition will be dp2 L and R equals to dp L plus 1 R, or I guess I'll put the double bars, dp L and R plus 1. So this is the first case. So what does this mean? This means that you already, so you know that dplr is a palindromic substring with no deletions, right? And so you want to consider deleting the first character at the front, which is this, or the back character, which is this transition. And I guess there's another case. So this is um, if we want to delete a character at this step. But we have another case. What if we already deleted the character in some previous step, right? So we have to make sure that the strings that the string that we add at the front and the back continue to make this a palindrome. So let's say that, I don't know, like ABCA, right? This is an almost palindromic substring, right? If we add like any two of the same letters in the front, then this will still be an almost palindromic substring, right? And so our other case will be dp2 L and R equals to dp2 L plus 1 R minus 1 uh, if uh, if this thing is true, right? So essentially we've already determined something's an almost palindromic substrate in some previous step, and now we want to add characters in the front and back, and we know that is still an almost palindromic substring, right? So this is if uh, almost palindromic, but we add letters to it now. So I guess for DP2 L and R, this is the only case you have to consider. Two cases you have to consider. We're either deleting a letter at this step, or we're not deleting a letter at this step. And the answer, well, so what is the answer? The answer is going to be like the max of R minus L plus 1 over all dp LR. That is true. And yeah, that's about it. I guess I'll show my implementation for reference. Okay, so the first part is the standard palindromic substring DP, right, that I mentioned at first. So we're gonna use this to compute like the almost palindromic substring DP. So your base case is gonna be like all length 1 strings are already palindromic. And then you're doing the transition that I just mentioned. And then for almost palindromic substring, you're gonna note that, so the base case is any length 1 string is automatically palindromic because you can just delete it and it'll be nothing. And an empty substring is palindromic. Or any length 2 strings are also almost palindromic because it doesn't matter if like you have like A, B or something like that, because you can just delete either one and it'll be almost palindromic. And then so here you just work off the transition like I explained. So initially your answer is going to be 2 because all length 2 strings are almost palindromic. And so you're going to either delete the first or the back characters at this step, or not delete at this step, but you deleted some previous step. And so and so you're going to add the front and the back characters to an already almost palindromic substring. And if this is true, then you take the max of the length. And that's about it. Do we have any questions, comments, concerns? Can I do a dry run? Um, I mean, okay. Um, I I believe I already explained ABCA before, right? So we have S equals ABCA, and then the answer is going to be, this whole thing is going to be an almost palindromic substring. Why? Because from our first DP, um, we're going to, from first DP, we're going to know that, um, let's see. Actually, this is not a good example because it's too short. So we're going to know that B is a palindromic substring, right? From the first DP, and then from our second DP, we're going to know that BC is going to be this palindromic substring from this first transition. Where is it? From this first transition, right? So essentially, look, we have B. We're considering BC, and we know that B is a palindromic substring, and so this will trigger this condition because it's just that without the second character, right? And so from that step, we're going to know that BC is the almost palindromic substring, and from this second condition here, now because we already removed the character, we can't continue removing characters, so we have to transition to the second condition, which is that um, that is true if we remove the first and the last letter, um, and and S of L equals to S of R. So we see that here, right? That's S of L. That's S of R. We see that that is equal, and we know that for BC, DP, L, and R, I guess it's L plus 1, R minus 1 is true. If we consider L and R as the first and the last letters. And so from this, we have all the conditions we need to make the second transition. So we have this condition, we have these two equal characters, and so from that, we know that DP, L, and R is true. And since L and R are three apart, we know that the answer is 4. So I guess that is a dry run of the first sample. Does that make any sense? Okay, well, can move on to the next problem, which I think is like easier than this one. You can look at my like speed. Solve the fourth one first. Um, so this is just a really standard try problem in my opinion. Um, so essentially, you want to select a subarray of the array such that the subarray, for the subarray, the difference between the minimum and the maximum is at most k, and the value of the subarray is the bitwise XOR of all the elements in the array. So for these problems, you always want to break it up into pieces, right? Both of these problems are kind of like two problems that are like stacked on top of each other, but those two concepts have nothing to do with each other. This is like almost the same thing. So just consider like this condition doesn't exist for now. So you must select a subarray such that you want to maximize the XOR of the subarray, right? And that is a really standard problem. They can be done with tries. So I'll explain how tries work a bit later, but just consider we have this magic function. Um, so consider we have this try, right? Initially store like a bunch of numbers, right? And we have this magic function called max XOR. try t, and like you input an integer, and it'll output the maximum XOR with some integer in try t. Okay, so essentially you have a collection holding a bunch of stuff, a bunch of integers, and now you can assume an efficient function that gets the max of XOR with some integer in try t. And so now going back to the problem, say you have an array called uh, a something, and you want to select some subarray such that the XOR is max, right? So how do you get the XOR of a subarray? Well, we can get the prefix XOR array, right? So consider this array P of I equals P of I minus 1 XOR A of I minus 1 over like I from 1 to n. And so what is the XOR of our subarray? The XOR of the subarray is just, say you want to get an XOR subarray from L into R. The XOR of subarray is P of R XOR P of L minus 1. Right? So essentially uh, you've reduced this conditions into two parameters here, just P of R and P of L minus 1. And so now that consider from you iterate I guess doesn't matter. Like iterate the right bound of the array. Okay, iterate R from 1 to n. And then you know that your current try array is going to consider all elements from a sub 1 all the way to a sub r minus 1. So when we call that max function, XOR function, when we pass in try, and we pass in a sub r. Wait, actually this is not a, this is p. We only care about the prefix. So p sub r. Then this will return the maximum XOR of some p of r, XOR p of r, such that L is before r. L is 1 to r minus 1. Right. So for now, we're just ignoring the condition that of like the minimum and the maximum difference, and we're just considering like an arbitrary array in the subarray of nums. So this is really standard stuff. So well, now we only need to consider what happens when we add that constraint. Well, it's actually like really easy. So what we can do is we can do two pointers, right? So we have a equals like something, and we know that your subarray is going to be consecutive. So we have like maybe some this array has like maximum minimum elements at most k, and we have like this subarray maybe, this subarray maybe, and know that they're monotonic, right? So the left bound always increases as the right bound increases, and so that is why two pointers work here. So at each step, we can make the try consider all prefixes up to the last point, right? So when we're like considering this point, we care about all the try elements from all the way from this point to like to whenever that condition doesn't satisfy, and so on. And so we could essentially run the same algorithm here, but instead of like inserting it all the way to like the from the array, uh, the try will contain elements from p sub l all the way to p sub r minus 1, where uh, like L and R are the longest subarray with max minus min at most k, given a fixed R. And so this is just a really standard two-pointers problem. And since you can insert and remove from a trie in logarithmic time, you can easily like add to a trie, remove from a add an endpoint to the right, remove an endpoint to the left, and get the XOR. Okay, well, that's about it for the algorithm. Now, the only thing I didn't explain is how trie works, but I'll probably just briefly explain it, but you should probably just Google it online, right? So, how trie works is consider you want to insert 10 to an empty trie, and so the binary representation for that is 1010. And for a trie, you have an empty root, and then you're going to always prioritize the most to the least significant bits. Oh, wait, am I like trolling? Wait, my screen died. Hold on, give me 1 second. Okay, we are so back. I don't know when it died, but um, we are so back now. So consider we want to insert 10 in this trie, then we're going to go from the most significant bit to the least significant bit. So we're going to have like something like this, right? Um, and say we want to insert like, I don't know, what's like a good number? 3. So that'll be 0011. And so actually that's not a good example. We're gonna insert like 1011. Actually 1100, whatever this number is. So this is what? I don't know, math is hard. 12. Um, so we're going to go down and we're going to see that 1 is already like in the trie, right? So, but we see that the second one is not in the trie here. So we're going to branch off here and then we're going to add the stuff, right? And since the the constraints are up to 2 to the 15, you know that the def is at most 15, right? So inserting is going to be log in time. Now, if you can imagine how deleting works, well, you just kind of do the same thing, but you do the same thing, go down, and then you delete as you go up, right? So that'll also be logarithmic time. And so to get the max XOR, what you want to do is you want to go from the most, you want to go down the trie, and then, so if there is a differing bit, then you're going to take it. And so say you want to get the max XOR with like, I don't know, 1, 1, 0, 1, 1. Yeah. Actually, no. 0, 1, 1, 1. Okay, so you want to get the max XOR of 0? Well, you see that 0 and 1 are different, right? You have a 1 path you're going to take. So you're going to go down to the first one. And then there you're going to add 2 to the, 2 to 3, right? Because this bit differs. And then you're going to go down here. So you see a 1 there. So you want to take the 0 path, right? Because that differs. So you're going to go down and you're going to add 2 to the 2 because this 0 path exists. And however, you see that you want to take a 1 here, but like this doesn't exist, right? This is like if you take this path, then you're going to add 2 to the 1 here, but this path doesn't exist. So you have to take this path. And because this has the same bit as, oops, uh, this has the same bit as this, you're not going to add your 2 to the 1. And then you're going to go down and you're going to get 0. And since 0 is different from 1, you add 2 to 0. And that's how you get the max XOR given some numbers in the try. And so that will always be also be login time because you're just going down the try. Yeah, I mean that's about it for the problem. I just have one doubt. Should not we add pref L minus 1 to pref R? Are you doing it one base? Yeah, I always do one base for my prefix arrays because 0 base arrays are just annoying to deal with when you're dealing with the start. And also, you're going to initially add the 0 in it because you want to consider, because the very start of a prefix arrays is always 0, right? That is the condition for if you have before the first element. And so I always 0 index my prefix arrays. Okay, so um, we have this really cool try class that you guys can take a look or probably steal from one of my submissions. And then we're going to build the prefix array here. And then we're going to initially add 0 to our try. And then we're going to do 2 pointers, right? And so what this check function does, it just makes sure that, you know, if we were to add this next element, then the difference between maximum and min is still at most k. And so we can't like possibly increment the right pointer if our current subarray violates this condition. And so that's why we have this check here. And then if that succeeds, we insert it into the multiset because I use a multiset to check max minus min. And then you add the right prefix to the try. And then you increment R. And then for here, you want the max element in the try such that it has a max XOR with p sub L. If you were to do p sub R, then it will also work. But I mean, it doesn't really matter. And then you're going to remove the left bound when you increment it. And that's about it. Are there any doubts? Solution with DQ is annoying. Multiset is better. All right, well, good for you, I guess. You can probably solve this like better constant factor, but it's Leetcode, so as long as it works, it works. Okay, well, I guess I'll wait for 2 minutes for any questions. If not, then I'll end the stream and go play Clash Royale. Any tips to do good after expert? Um, I don't know. Solve problems. Yes. A very, very, very hidden technique. Solve problems and play Clash Royale. Okay, well, I guess that is all the questions from the 10 viewers in my chat right now. So I guess it's like almost midnight for me. So actually, no, I am not gonna sleep. I'm gonna stay up playing video games. So